Good evening, everybody. Good evening. Hi. Everybody cold? Yeah, okay. Let's see. I have plenty of slides, so you probably will keep running with me here. So let's see where we can take this. So I want to talk a bit about containers and like our story from Elastic, from where we started with containers and how we went all the way up to operators by now and what we kind of learned along the way or stuff that we're doing and trying out. So I work for Elastic. I think my official job title is developer advocate, so I mostly travel around and just talk about stuff and don't work, which is very nice. If you've never heard of us, we do some software, Elasticsearch, for example, and Kibana on top of it, and Logstash and Beats. And some of that you probably want to run in a container. So this is kind of like where we want to start. So just quick show of hands. Who is using containers in general? I assume pretty much everybody, okay. Who is using containers in production? Also almost everybody. Who is using stateful stuff in containers? Okay, that's fewer, but still quite a few. Okay, anybody using our images out of interest? A couple, okay. And really ours or those built by somebody else? Ours? Okay. Because that used to be tricky. By now we've taken control of quite a few, so yeah, accidentally you won't run others probably. So I'll quickly talk a bit about Docker images and kind of like what we learned and what we think are good practices there. Docker Compose shortly, a bit of about Helm charts and then operators at the end. So let's see where we can take this. So everybody loves or hates Docker. By the way, I think this should be the right Docker image. This is also the size of your average container by now. And we have this internal saying that Docker is the world's most heavily funded college project because that is how stable their APIs are most of the time. Or at least that's whenever something goes wrong, we have some of those opinions. Anyway, but containers are here to stay. We kind of jokingly say they're the new zip format that everybody has to use, so there is no way around them. But for us, do you have to use our software in containers? We don't really care. They are just one way of getting stuff done. We have Debian and RPM and MSI and TarGZ, and we support multiple orchestration systems to roll out our software. We don't really care. You totally can use Docker, but we don't have very strong opinions about that. But Docker has this interesting thing that it is not really without issues, because a lot of people think, well, it's a container, everything is wrapped away, I don't need to know anything about it anymore. But that's not exactly true. So just some things that we often see that we're not so happy about. The first thing is we want to run everything as root in our containers because it's in a container anyway, and we don't care about permissions. Does anybody do that or want to do that? No? Okay, good. Because I think this is the right image that the snake has been replaced by the whale, and this is what people do in Docker, that you just run everything as under 777 and root. So you don't really care about security. And I call this one of the cockroaches. That's something that when we were using regular service, everybody said, well, running stuff as root is a bad practice. But now with our Docker images, we have people coming back to our repository and opening issues and saying, we want to run your software as root because we run everything in our containers as root. And we're like, why would you do that? And no, you cannot. Because basically we have a check when you start up Elasticsearch, for example, and it will system exit if you run it as root. We check for that. And the only way you could do that is that you would fork the source code and actually comment that out. There is no other way around that, and we won't change that. And the other thing that we insist on is that, well, we have a specific user and a user ID and a group ID that we run that on. And the problem is that a lot of people don't expect that. And that's one of the very common issues that we have when people open a bug and say, like, it doesn't work. We were using other images. They were mutating some bind mounts, but you don't do that. And what we especially like is when they say, like, I prefer simple fire and forget Docker containers, which is not really the best approach for stateful stuff, in our opinion, because that will mean a lot of pain in the long run. And also, what I always imagine what people are then doing with their containers is something like this. That's pretty much what people are then doing with their containers. And we try to have something for production, so this just doesn't work well together. We don't mutate the bind mount. You should not change anything on the host from inside your container. Don't do that. Don't expect that. It's not a good practice. The thing is, if you don't know Unix and you don't know file permissions, then Docker is all confusing around that. You're just going to reinvent stuff that has been around for a long time, unfortunately. So, yeah. Another thing is latest. Is anybody using latest for external images that you're consuming? Because we don't have the latest tag. And I think we got a GitHub issue for that once a month or so when somebody said like, you're missing the latest tag. And we were always like, no, we're not missing the latest tag. You should not have a latest tag. Like it's there, it's not there for a reason. And this is one that I call the zombie. Something that should have been killed by evidence a long time ago, like with regular dependencies, but is still around and you're not getting rid of that. And the problem is that Docker Hub is kind of promoting that, because if you look at Docker Hub, even though our images don't have latest, that is what by default Docker Hub suggests what you should use. And if you copy that, it will fail because we don't have latest. And then people always open an issue and say like, this fails because there is no latest, and we're always, yes. This is intentional because Docker Hub is stupid. Or maybe not stupid, but it should be configurable. We would love to add the latest version there and people just copy that, but that's unfortunately not possible. Then sometimes people say like, what about the major or minor version? Because for example, the problem with latest is mainly that if I spin up a cluster with 3 nodes today, and in a few months I add 2 more nodes, they might have a new major version. And then the cluster might break in an unexpected way. So maybe we should just pin it to the major version or the minor version. Does anybody want to do that? At least with Elasticsearch, that's not going to work out so well, because Lucene is kind of picky. A shard that you have created with a new, or like some data that you have created with a newer version, it doesn't want to migrate back to an older version. So you might have stuff where if a node dies, the data cannot really move around to the older nodes anymore, and you might have an unbalanced cluster. So that's also not a good idea, especially for our use case. So that's something we don't support as well. The other thing that we probably don't do that well right now is what's even in a tag. If you look at that, you see that some tags are X month old and another tag is 1 month younger, even though they're exactly the same version and we normally release those at the same time. The problem was we had a bug in there, and right now we only have like the Elasticsearch or Elasticstack version in there, but we don't have a version for the Docker image. So if we have a bug in the Docker image, we can just overwrite the tag, which is not a good practice, and you probably won't see it, but we would be overwriting that tag. But I only know 1 or 2 instances where we have ever done that, because you shouldn't do that. Though we have the labeling schema where this is probably way too small for you to read, but we have various labels on the images, so you can actually see pretty well what is in there. The other thing that is kind of tricky now, you used to work on your software and everything was nice because you had your dependencies and you released a new version when you had a security issue. Now with Docker, you suddenly have a full tree of dependencies because you have the base image and you also have, in our example, for example, with Elasticsearch, the JVM as a dependency. What do we do with old images if there is a security issue? Do we re-release them? No. Basically, you have to move forward. We don't re-release old images. Also because we don't have the version in there. That's something, yeah. Maybe we will add new images later on. Another thing that we can sometimes see is that people want to do runtime mutations. Who wants to do runtime mutations? Like you start up the container and then it does something, like running a shell script. Like we have seen feature requests like this, like you just add a shell script and whenever you start the container, you just do various stuff like install software into the container whenever you start it up. That's really not what we want to see, because we want to have immutable images, and you create that, you push it, you pull it down, you use the same thing everywhere. Don't do that. Also don't customize stuff too much through like environment variables. Like if there is some specific environment variable set, install some additional software or so. We're not big fans of that. Stuff like that should just be handled through a regular Docker file where you add something, you bake the right image, and you roll that out everywhere. Because otherwise it's getting very unpredictable. Like if something fails on one node and we are missing a plugin that you have on other nodes, it just might not work that well together. So don't try to do that. Something that, for example, sometimes people struggle with, we have like credentials which you can put into a key store. You can also build those through containers, and then you bind mount the key store. Like here, I just generate the key store. The details don't really matter that much. What is much more interesting is then that you can bind mount the key store here, Docker Compose example, but the same works for Kubernetes and other systems. The thing is, your key stores or your passwords probably have a different life cycle than your containers. That's why you don't want to bake them into the image. Because maybe you want to replace your key store, but you don't want to upgrade your Elasticsearch. Or there is a new version of Elasticsearch, you want to upgrade that, but you don't want to rotate your keys. So you want to have two different life cycles for those, and you don't want to bake those in there. The same goes for SSL certificates, for example. You want to be able to rotate SSL certificates without rotating images. So don't bake them in there, just bind mount them and keep them outside. Something that is maybe a bit more of a discussion is base images. Who has very strong feelings about base images? What are you using if you have strong feelings about base images? It's tricky, okay, yeah? We agree. We agree with that. Like, we have tried stuff and we have failed a bit. So one thing we have tried is for Elasticsearch, we tried Alpine. Initially, because it was when we started like good 3 years ago, so it was like, oh, it's where everybody is going and it's very small and it's the future and you should use that. But we were not that happy, especially because our other projects were using Ubuntu base images, mainly because I think, so Kibana is a Node application, and I think back then Alpine didn't officially support Node. And Logstash is JRuby, and I'm not sure if Alpine by now supports JRuby or not, but at least back then it didn't. And we basically said we cannot put something on an image that doesn't support the platform that we want to run on, and then make it an official image, because we cannot provide the support for the Alpine image, basically. So we would be kind of stuck there. But we had these different images, and we were a bit unhappy, and also we ran into various bugs around Alpine, because MuCL is nice and new and shiny, but it's not as battle-proven as glibc. glibc might be old and ugly, but it has seen a lot of stuff. And like, you're unlikely to run into many new bugs, or at least that was our experience. Like with MuCL, we were running into much more issues than with glibc. So what we did is we switched back to one shared base image, which is in our case CentOS 7 now, and that's where we run everything on. Which might not be the most popular choice in Europe, because CentOS might not be so widely used here. But since we have a lot of customers in the US, like CentOS is kind of the easiest choice there. And that's what we are using there. For us, the upside was there. We have a similar base image for everything. So you don't have to wrangle Alpine for some images and then Debian or Ubuntu for others. You just have one base image, and you also share the layer. So if you pull down all the components, the base image is larger, but it's a shared layer anyway. So even on your testing systems, you will just share the layer, so you don't care much. The other thing is, if you need the JVM like we do, your images would not be very small anyway. Like, yes, you can have a 50 megabyte base image, but if you then add 150 megabytes of JVM, the advantage is not as big as it used to be anymore. And like I said, glibc is a bit more tested, or at least in our experience, or at least 3 years ago, MuCL was throwing funny bugs every now and then, so we were not super happy about that. The main thing is that the size changed of our images. So our images are also a bit like a whale, admittedly. The question is if you care much about that. So I've listed here various image sizes. Probably it's easier to see in the table. You can see 5.3, that was the last version where Elasticsearch, for example, was on Alpine, and the other two were on Ubuntu. And then we switched, and I just took the last major version of all the versions to show how big the images are. So yes, they got larger. Is anybody very concerned with the image size? Yes. Why?
1 gigabyte.
Yes.
That's quite big.
Yes. But the thing is, how often are you deploying that? It's not like your own application. You're not rolling that out on a daily basis. So it's not affecting you that much. And B, since we have stateful stuff, probably your data size is more than 1 gigabyte. And that's much more of a concern in the long run. So if you have 100 gigabytes of data that you need to worry about, the 1 gigabyte of base image is maybe not your main concern. So if you have like your own application that you want to deploy 20 times a day, I can see the point that you want to have small images. People normally complain that we release too frequently, like we might have a new minor version every 6 or 8 weeks or so, and a patch level every 4 or whatever. But that's still not going to kill you in terms of traffic. Also, how many instances of Kibana will you run? 1, maybe 2 or 3. Multiple Elasticsearch images, or instances. But if you have that and you have 100 gigabytes of data, you probably don't care so much about the data size. So for us, yeah, it's a bit of a concern. It's a big image. On the other hand, for stateful stuff, I feel like it's less of an issue. The other thing that sometimes people say, you could use a slim Debian image. We don't trust the JVM on Debian that much, because Red Hat has just much more JVM experience, and they seem to be knowing better what they do. Also, Debian had some bad glitches that they introduced into their JVM, I think, in the past. So we trust Red Hat a bit more. That's why we went with Red Hat images in the long run. People are always asking for multiple base images. We might do that at some point. I'm not sure we really want to go there, maybe. Sometimes people ask for Windows-based images. Does anybody want Windows-based images? I'm just curious. Because Windows-based images I could almost understand, because I think with modern versions of Windows, if you have a Windows host operating system, you can skip that small VM layer in between if you have a Windows Docker image. Though I don't really know anybody using Windows Docker images. And I haven't touched Windows in years myself, so I'm not really sure how well it works. And the main thing is, even though people ask for it, I don't think anybody in our team really has much Windows experience, so I'm not sure we really want to go there. So don't hold your breath for Windows images. Okay, next up, you can run stuff on Docker Compose. Who uses Docker Compose, just out of interest? I assume that is mostly for local development or demos, right? Anybody using it for anything else? Production? Production? Small website, okay.
Some legacy things.
Legacy, okay.
For example, Sentry.
Sentry, yeah?
Be a, like error logging
Yeah, yeah.
application. So we just deploy it with. It's like local, but on the server. So it requires one server.
Ah, okay. And they only provide Docker Compose files? Or did you write those yourself?
No, they provide.
Those are provided. Ah, okay, okay. Yeah. I know Armin Ronacher from Sentry and others, so yeah. Okay. Yeah, for what we see, we mostly assume they're demos. For example, to run Elasticsearch, you could do that. That would be here the minimal example. This is Elasticsearch, probably a bit small to see, but you can see we're generally using our own registry, though we do push the same images to Docker Hub, so it doesn't really matter. You could just say Elasticsearch as long as you provide the version explicitly. We do want memory locking, so we don't have swapping. I'm just setting a heap size here, and then say I have a single Elasticsearch instance, and the entire thing has 1 gigabyte of data, and I bind mount that data directory. Nobody would want to write persistent data into the container, right? Neither for performance reasons, and nor because if you replace your container, it will not be such a fun day. And then you could just throw Kibana on top of that. So this is the continuation of the previous slide. I basically link my Kibana image to that, expose it on the default ports, and this is the bind mounted directory. That's all there is to that. We do have like a demo thing around Docker Compose that you can just do Docker Compose, spin up into our entire stack and demo it. The problem is nobody wants to maintain it now because we have people doing production stuff and nobody wants to take care of demos. So we are not really sure where to put that, but we see. Probably we should keep maintaining it. But most people have probably moved on to Kubernetes anyway, right? So who is using Kubernetes, just to get an idea? 1, 2, okay, 3, not that many. Is anybody using Swarm? Oh, that's surprising, okay. And you're still building new stuff on Swarm, or you're sticking, or it's just legacy basically? Legacy, okay. Yeah. I still know some diehard Swarm fans, and they don't want to admit defeat, but I'm afraid it's too late, and it's not going anywhere. Is anybody using Nomad? No, okay. I guess Mesosphere is also another topic. Oh, you're also using Mesosphere. Is that also legacy, or is that?
Yeah, right now we are migrating to Kubernetes.
Okay, so you tried everything basically. Maybe you want to try Nomad as well?
We tried it, it doesn't work.
Okay. Fair enough. Okay. But you didn't bring that to production, only the others.
Yeah.
Okay.
Managed to crash it in 2 hours.
Okay. Fair point. Yeah, I think even Mesosphere or the company behind it is now moving to Kubernetes and they want to do Kubernetes services. So that's pretty much, I mean, software that is always relative, but I don't think it's going anywhere anymore. So that's probably, yeah, pretty much the end there.
Software Foundation project, so
Yeah, sure. It will live forever in the Apache Software Foundation, but it's one of the more zombie projects in the Apache Software Foundation, which happens. Yeah. Generally, Kubernetes static configuration to deploy your resources, which looks something like this. So you have your master node where you have your API server, your scheduler, controller, somewhere etcd in the background to actually keep all your state. With kubectl, you control it, and then you have your specific nodes that would run your workload. What you also get with Kubernetes in general is lots of this. Lots and lots and lots of YAML. Who likes YAML? Okay. That's the Stockholm syndrome, right? You get so used to using YAML that at some point you start liking it. Now we can discuss that. Does anybody know what the problem is with that one, for example? That one would be like a simple, you try to bind port 80 and 20 in Docker. This will go terribly wrong in a probably unexpected way. Does anybody know what happens here?
those should be streams, but
Yes.
I don't know how it would work.
Yes, if you would quote them, your life would be much better. Because YAML has this interesting attribute that if you run that through a parser, so if you run that through YAML lint, for example, this is the output. So the first one will be quoted correctly. The second one, the port 20 mapping to port 20, is getting a very different or weird number. Does anybody know why? Container ports lower than 60 with that colon syntax will be interpreted as base 60. And that is how you get to that number. So unless you quote that, this will go wrong. And it's part of the Docker documentation for the compose files where they say, please be careful with that one. If you have low ports, you might run into that. That's just one of the fun things that you might have with YAML. Yeah. Yes. For higher, it's not expected to because, yeah.
And it's not like YAML itself, but it's Docker feature.
No, it's in a specification, I think, in YAML. But the YAML specification is very large, unfortunately, and has many interesting things. Or you know the classic when you have like a list of countries and you have Poland and Germany like PL and DE and whatever, and then you at some point have Norway, NO, which will be evaluated as Boolean false, for example, unless you quote it. So YAML has a lot of interesting things that you need to be aware of. Also, like if whitespace indentation should make a difference or not is very much like something you could discuss, but that's a different discussion. One thing for us in specific that you couldn't use Elasticsearch up until Kubernetes 1.8 because Kubernetes didn't allow dots in environment variables, which is generally totally fine. It's just Kubernetes didn't allow that. And unfortunately, our configurations or the way we pass arguments in often needed dots in environment variables. So that would not work. But since then, it's generally possible. So, moving on, Helm charts. Is anybody using Helm? 1, 2, 3, 4. Okay, some are using Helm. In the end, it's a packaging format to support templating and more complex resources. The main thing about Helm is that it basically builds on Kubernetes primitives. It doesn't introduce like new concepts. It's just wrapping the existing primitives. So you have stateful sets, services, you have deployment. All of that are there. They're just basically in those templates that you have. So for example, we have Helm charts, which are beta right now for Elasticsearch, Kibana, MetricBeat, and FileBeat. You can get them on Helm charts and you can use them. For Elasticsearch, that's a stateful set, which could do a rolling upgrade as well. And basically, when you would do a rolling upgrade in the stateful set, we would always take out one node, replace it, wait for the cluster to become green again, so the node joins again and is fully integrated into the cluster, and then rotate out the next node. So that works and is fine. We generally only support it or test it, probably works elsewhere as well, but we only test it on Google Cloud. And with the default storage of PD SSD, which is network attached. For better performance in more recent Kubernetes versions, you could also use persistent volumes or local persistent volumes, which would give you better performance, which you could use as well. The big thing about Helm charts is basically that they're very unopinionated. So it's pretty much you use the the Kubernetes primitives, and then it's just pretty much like any other image that you're using. For example, for us, you just expose the environment variables to configure the image, or you can just bind mount secrets or key stores. So it's not like we build those for you, or we take care of the configuration and have a specific way of handling those. But it's just like it would be you would use that like with any other Docker image, or with our Docker images at least. So it's not that we have a specific way of configuring stuff there. Because it's unopinionated, it just works like many other images. But that's also a feature, because it's kind of like much more similar to, or you could find multiple ways, because you can just build it the way you want it, and it doesn't force you into one specific path of configuring certificates, for example. Just as a quick example, you could run this on Minikube. We have an example here. For example, you just pull the right Helm chart. Then you can say like, I want to install that for Elasticsearch, and optionally you could specify a version. Here I'm going for 7.3.1, which is the latest one anyway, but if you want a different one, here is where you could specify that. For Minikube, you will need a storage class and a provisioner that you need to add, and then you just have a configuration file. This is one single file. I've just broken that up for better readability over 3 slides. So we have a soft affinity because, well, it's all running on one single virtual machine. So we don't need to distribute that. I use a pretty small heap, but that will start up and run. And I also don't give the instance a lot of CPU or memory. So that is pretty small here. And then yeah, you have read-write once as the access mode and the standard storage class. And that's pretty much it. So that is the entire configuration. That's how you could spin up one locally. But people always want operators. And what operators basically do is they provide an interface that allow you to customize the management of your applications. And what they're based on is custom resource definitions, CRDs. And rather than before, we were basically thinking in Kubernetes primitives like pods and services and stateful sets and secrets and everything. In an operator, you think more in higher level services. So for us, for example, you would think more like in terms of this is an Elasticsearch service, and this is a Kibana service, or this is an APM server that we also support. And then you have a custom controller that basically brings everything to life. So that will do upgrades, that will do certificate management. And this is all very opinionated, because these will, if not provided, they will generate certificates for you or set up security automatically. So these are kind of opinionated and have a specific approach, but you have to care for less things. Kind of the downside for us is that they are much more work to build and maintain, but they do take kind of like a bit more, or bring in a bit more magic into running your images on Kubernetes. There used to be one popular operator from the community by Pires. I think he runs multiple other operators. He used to have the most popular Elasticsearch operator as well, but he recently stopped providing that. And we kind of try to fill the gap. We have an alpha operator. We're pretty careful with versions, for example. Right now it's alpha that has Elasticsearch, Kibana, and the APM server. And it's called Cloud on Kubernetes, if that is the best name we can discuss. But yeah, if you want to run that, bring up Minikube. And for example, I cannot run that on my laptop anymore because that needs 16, or that's recommended to use 16 gigs of memory just to run that on Minikube, and that would not work on mine here. Anyway, what you then do is, right now we are at 0.9, there will be 0.10, we are not going for GA next. But basically you can fetch the current version, and actually we call this, I think it's called Elastic Cloud Kubernetes or something like that, and it's always ECK. So if you see ECK, that's the thing. You can monitor that you have actually pulled that stateful set down there, and then you can deploy it with this YAML file. And we'll just take a quick look at what you would need to configure to actually run that here. I hope that's readable. So what you can see here is we have an Elasticsearch Kubernetes Elastic in an Alpha 1 version. That's the API that we're using here. We call it the Elasticsearch sample. And then we are running this in version 7.3.1 with a single node, and then we just give it 2 gigs of memory. And then we do some other configurations where we set the specification for how to write data and limit that to 2 gigabytes as well. We could bring in the APM server, which is, well, APM, pretty much the same thing, also in Alpha 1. Here you just specify a single node and the version again, and it binds to this Elasticsearch version that we have defined on the previous slide. And finally, the same thing for Kibana, which looks exactly like the same thing. And then you could just check the status with kubectl get, and you would need to expose, for example, Kibana to make that accessible, but then you're done. And then this will automatically, even though you haven't configured it, for example, this will generate a self-signed certificate for you, and this will also set up security. So the Helm chart wasn't doing that. The Helm chart, you would explicitly need to tell, like, here is my TLS certificate you should use, and bind mount that into the container. Whereas here, the magic is being done in the background. So what you need to do in the final line here, this is how to extract the auto-generated credentials or password for the, I think, the Elastic user, which is the default user. This is how you would get the credentials for that specific user. And if you want to change anything on that one, you would just change it in the file. Like, you could change the version or the size of an image or the number of images or whatever. And then you just apply those through that configuration file, and then it would do everything for you. So what this basically does is, at first, you deploy the operator. And that has these resource definitions, the controllers and the controllers managers. And then you create that configuration of one or more configurations that you want to run. And then the operator basically observes any changes to those, and then rolls them out to Kubernetes and creates the resources that you have actually defined. This one doesn't mention the APM server, but let's assume we are just using Elasticsearch and Kibana for this one here, and you don't need to do anything else. This one is actually supported on quite a wide range of Kubernetes environments, so even OpenShift is by now supported. What we are transitioning to right now is to use stateful sets to support rolling upgrades and reuse the volumes in the background, because this is pretty much the standard way. The colleagues were maybe a bit too opinionated when they started building that, because they started building their own storage backend, which might not have been the right thing, especially since we started to re-implement more and more things that stateful sets already give you. So that, yeah, we're trying to fix that. For storage, you have 3 options. You can use mtdir or host path, which is basically just on a local host. Sometimes if you have very small data sets, like you have a demo, or you have something that you could like regenerate the data very quickly, that might be good enough for you to run that there, but it's normally not for durable data. You could use persistent volumes, either local persistent volumes, which should have the best performance, but well, the node attachment is kind of restricted. Or you could use something that the cloud provider is giving you. For example, something network attached. And then that normally scales and just moves around as you need, so that's a bit easier to handle, but might have a bit more network overhead, but should work. What we started to do is we implemented our own container storage interface, though we probably won't finish that for GA, and the idea was to have something if you run on bare metal or a self-managed cluster, to use a nice storage backend there, but we are not sure if we really want to go there now. We'll see. Something that's more interesting is like security. CRDs require cluster admin level privileges, and our containers also, or at least the Elasticsearch containers, need privileges, so you can set some credentials or some limits for those. There's no way around that. One thing that you need to do is, or need to decide is, do you want to run the operator in a global namespace or in a single namespace? The global namespace is basically you have the operator running once for everything, and then you can spin up based on that single namespace, the Elastic System one. You can spin up all your teams clusters. So you can see we have an app team, we have a SecOp teams, and we have a dev team. And they are based on a single operator. However, that might not scale very well for very large environments, and it also needs elevated privileges on the cluster to use those. So what you might want to do instead is, but that has its own trade-offs unfortunately, use a single namespace. That where you would run the operator inside one namespace, and then just for that cluster, whereas you run another operator for another namespace. However, in terms of resource usage, that's a bit more wasteful, of course, because if you have 5 clusters, you need to run 5 operators. Also, if you want to have some global configurations or some licensing, like if you have licenses for 5 clusters, that's not going to work out that easily then. That's a bit up for discussion, whatever is best for you. Yeah, there are lots of other operators, by the way. You can go to Operator Hub and find lots of operators, including ours, which is this one here, but you will have Kafka and MongoDB and CouchDays and CockroachDB and lots of others. So you can just pull all those opinionated ways or operators to use those, and then go wild. So to wrap up, whenever somebody says like containers are disrupting the industry, I'm never sure if they mean it in a good way or in a bad way. Disruption as in taking the service down is sometimes also what happens. Because people often ask us like, can I run Elasticsearch on Docker or Kubernetes? And we always say, yes, you can. It's just one other format to do that. The question you should be asking is like, should I run it on Docker or Kubernetes? And for that, we're always like, maybe. Like, do you run your stateless stuff already on Docker in production or on Kubernetes in production? Because that's where we would start. If you don't know Kubernetes or Docker, don't start with a stateful service. It will just end badly, and you might lose data, or you might not like us because stuff breaks in an unexpected way, so don't do that. Sometimes people are confused, why do we still have a Helm chart and the operator? Why do we have both? Because they're just two different approaches. Like the Helm chart is like this unopinionated thing that is behaving a lot like many other services, and like if you want to run 100 services, it might be a bit easier to make that fit into the way how you run everything. Whereas the operator is very opinionated. It does things in a specific way, and every operator might do things in a different specific way. But if you're mainly interested in running like 10 Elasticsearch clusters, that's probably what you want to do because it will make your life easier. If Elasticsearch is just one of many services that you want to run, maybe the Helm chart is easier to customize to how you run everything else. And it's also probably easier to understand looking at the code. On the other hand, the operator will do more work for you and do like scale up.
I guess we're at the end. Well, okay. I guess we can do a Q&A. Let me come out. Questions, discussion, comments? Any questions? No, we're pretty much done. It's okay. And I will publish the slides, so I think I only had 1 or 2 more. Yeah. But we can still do Q&A. Any questions?
Because I feel like everybody is getting cold and tired. And we're almost out of time anyway. Any questions? Anything you want to fight me over? Because you disagree on some way to do it.
How much time did it take you to create those operators and Helm charts? Was it hard?
So that's actually a good point. So we have 2 different teams. So the Helm chart is done by a different team than the operator. The Helm chart is done by like, we call it infrastructure, which is internal tooling. And it's mostly 1 or 2 people doing that. So it's it's not a side job, but it's only like 2 or 3 people working on those, and they have other things to do as well. Because it's not doing as much magic, and it's less code and easier, and also works with a lot of versions in parallel, because we don't really care so much how you generate certificates or how you set up security. Like, you can do that, but it's not baked in. Like, it's more in your templating, so it's mostly templates that you stitch together. Whereas the operator is done by a dedicated team, and there are at least 5. Like, we have dedicated person for documentation, and I think we have 4 or 5 engineers, and like, that is a much bigger operation. Like, the operator is kind of a bigger investment, and also where more resources will go in the long run. Right now, we have a cloud service that is also running on Docker, but it's so old that it was kind of like started before Kubernetes had one, so we had our own orchestration. Maybe in the long run, we might want to use that as well for that. We'll see. So that's a much bigger investment, and that's part of the cloud team. That's why it's also called Kubernetes Cloud. But that is like a bigger dedicated team, and they're adding more and more people just to have more features and also bring out new versions. But that's, since it's opinionated, for example, it only supports 6.8, I think, and then 7, like more recent versions. Whereas the Helm chart should also work with older versions back there. But for example, since we're so opinionated for the operator, we require security. Whereas in a Helm chart, if you don't want to add security, that's up to you. We don't require it. It's probably a bad idea, but you don't have to do it. Yeah. But yeah, it's 2 different teams. On the other hand, like, sometimes I think maybe it's kind of weird to have 2 different teams working on something similar. On the other hand, maybe it's good to have some competition, basically, to see what some are doing and what the others are doing, and just have... It's 2 different solutions to a similar problem, but it's a different approach. That's why we still think it's okay to have both, because some people will pick one and some the other. So we try to cater for everything and see where that will go in the long run.